Okay, we're going to begin our study of aquatic ecosystems. There are two main types of aquatic ecosystems. There are lentic ecosystems, which are slow-moving bodies of water like ponds, lakes, and reservoirs. The difference in those is that ponds are generally smaller but mostly shallower. Lakes, often if it's over 10 feet deep, they'll call it a lake. And then reservoirs are kind of any size, but they're man-made impoundments, so they would have a dam on them that holds the water back from a stream. And then there's lotic ecosystems, which are faster moving bodies of water, similar to like streams, creeks, rivers, brooks, all those things. So we'll start with lentic ecosystems today. What's important to know about any of these from an environmental science perspective, because we're going to be looking at the health and the quality of them, is that the size of them and the flow rate is what determines how well they can deal with and recover from pollution. So there's something called resident time or retention time, which is the amount of time it takes a body of water to empty out all of its water and completely refill with new water. Obviously, it doesn't work like that. It doesn't run dry and then fill back up. It's constantly cycling through, but resident time is how much all of it would take to go through. And that is equal to the volume of the lake, and that is in gallons, liters, cubic miles, meters cubed, any kind of volume, divided by the outflow. And the outflow is a rate. Okay, so that's volume over time. So cubic feet per second or cubic miles per year or something like that. Okay, so resident time is volume over outflow. And some kind of history on these sort of things. If we look at some local things like Lake Erie, for instance, this was considered in the early 1970s to be a dead lake. There was absolutely nothing still living in the lake. It had been so polluted. And the Schuylkill River, which runs down through Norristown and Conshohocken and down through Philadelphia and into the Delaware River. That was extremely polluted. I had a biology teacher when I was in school who, when he was a kid in the 1960s, had gone swimming in the Schuylkill River all the time, and the kids would come out just covered in black pollution. Okay, now both of them are a whole lot cleaner than they were in the 1970s. Schuylkill River took less time to clean up because the water's flowing through a lot faster, but Lake Erie took a couple decades to really become clean, and now it's quite a clean lake. So, the important part there is that aquatic ecosystems actually can cleanse themselves because the hydrologic cycle naturally replenishes that water and keeps it flowing through. So it's almost as if you had stuff in your sink and you are flushing it down your drain with, running the water. That's basically what happens here. Two important things must happen. First, the source of the pollution has to be eliminated so that it's not continuing to come in. That's the most important thing. And second, you have to give it enough time for the resident time of that water to completely replace itself once the source has been stopped. Okay, we'll be looking at the Green Lane Reservoir as a local example, and we'll look and see what the pollution levels are in the Green Lane Reservoir, what type they are, what kind of an effect they're having, and we'll look at the resident time and the volume and the outflow and see how long it will take to really cleanse itself and can or will we be able to stop the pollution. But if we're going to stop the pollution, you have to know where that water is coming from. So remember that any pollution in the reservoir is the sum of all of the pollution coming in from any of the inputs, streams, drainage ditches, springs, rivers that feed into that reservoir. Okay? Okay, so remember how this works. Natural hydrologic cycle. You got precipitation coming down from the clouds. It's either liquid rain or it's snow. Eventually that snow melts. Both of those things will turn into surface runoff. Run across the surface of the land, get into streams, get into rivers, then those flow into lakes and reservoirs. Some of the surface runoff might actually get infiltrated down into the groundwater, but a lot of that groundwater will then get saturated and then flow into streams, rivers, and lakes as well. Okay? And then eventually it will flow down to the ocean. All right, so that's how the things get sort of flushed out. Let's focus on lentic ecosystems a little bit more here. So when we get into what these ecosystems have, you've got surrounding the ecosystem is terrestrial plants. These are where those riparian buffer zones are going to be that we talked about before. But we're not focused on them right now. We're kind of looking at the water's edge on out. So there's a zone here called the littoral zone. Littoral zone is where all plant life is going to be in the lake that is rooted to the bottom. And then you've got the limnetic zone, which is also called the open water zone. And that's everything in the middle of a lake or a reservoir, beyond where plants can be rooted. Okay, littoral zone is broken up into 3 different zones, and we'll look at each one individually. Emergent zone, floating leaf zone, and submergent zone. And then the limnetic zone is broken up into the euphotic zone and the benthic zone, which sort of overlaps into the littoral zone a little bit. Okay, let's look at each one a little bit more here. So the littoral zone is made up of these 3 zones here. And wherever you have plant life in the lake, that's where you're going to have basically the nursery grounds for the organisms of the lake. You're going to have the small organisms, baby organisms, fish, crustaceans, that sort of stuff. They'll be around where there's food and shelter. So these are critical zones in a lake. We need to have a good supply of them to have a healthy lake. Focus on the emergence zone. Here's where you're going to have plants rooted into the bottom of the lake bed, and they're going to be emerging from the water. Okay, so things like cattails, which have those kind of fuzzy brown things that look like cats' tails on the ends of them coming out of the water. You got bulrushes, which are like little reeds coming out of the lake, wild rice. Okay, these have lots of light, lots of water, and there's plenty of nutrients coming from the shoreline. Get out into the floating leaf zone. Here's where you find things like water lilies, which are lily pads, which have long stems that go down and then root into the bottom. You have duckweed, which is tiny little floating circular leaves, like tiny lily pads. And then pondweed, things like water hyacinths, that sort of stuff. They float near the surface, they capture sunlight, and they are rooted into the bottom, so their leaves are floating. Then you've got the submergent zone, where you got things like stoneworts and coontails, and Elodea would be an example of this. It's not really that prevalent in our area, it's not native. But the plants are rooted into the bottom. Water's too deep for leaves to emerge. So it's important that you have good light penetration into the water, because if you don't get it deep enough, you won't have plants growing at deeper depths in any of these submergent zones. Okay. Then you move out to the limnetic zone, the open water zone. Here the water's too deep for plants to grow because they can't root and still get sunlight. So we're out beyond where sunlight reaches the bottom of the lake. Okay, and you've got a euphotic zone and a benthic zone. The euphotic zone does still have a lot of photosynthesis taking place, and this is coming from plankton. So phytoplankton like blue-green algae, which is what you see here, regular diatoms, green algae. This is green algae, this is blue-green algae, and diatoms. They produce more food and oxygen than any other producer group in aquatic ecosystems. We often don't think about them as much. We think of the aquatic plants, but the photosynthesis, most of it coming from the lake, is coming from the phytoplankton. At the bottom, you have the benthic zone. B for bottom, B for benthic. It's the lowest level of the ecosystem, or even in an ocean ecosystem. So there's no photosynthesis taking place here. We're talking about the sediment on the bottom and then some of the subsurface layers, which are called benthos. Okay, there are organisms there, just not photosynthetic organisms. So what do you find there? You find a lot of, crayfish scavengers, maybe things like catfish, snails, mussels. These are at the highest risk for long-term effects of pollution because anything getting trapped in the benthos is not going to flush out as easily because it's not flowing out as easily with retention time. So they're constantly being exposed to it when other things living in the limnetic zone and littoral zone are not. So this is about the end of part 1 of the Lentic ecosystem videos. There's a second video that will kind of go over how things change over time. So finish this one and then go on and watch the second one.